All right, we're back. We've been talking arrays, and we're going to add to some of the stuff that we've learned. We're going to talk about initializer list. So here I have a construction statement. That's a me term. I come up with that, right? We have a double array called values, and it is going to point to a new double array with a length of 10. When this is constructed, each element in the array will be initialized with the corresponding default value. Okay, think back for a moment. What is the default value for double? Since this is a double array, we're going to get the default value for double. So this will be filled with 0.0. So this array that has a length of 10 is going to have 10 0.0s, right? There is an alternate syntax in which we can actually specify what values go in immediately upon construction. Take a look at this example. Here I'm declaring an integer array called nums, and I am setting it to 2, 43, 18. Not only is this going to create our array with a length of 3, but it's going to initialize the corresponding elements to the values shown here. Right? So nums at 0 will be a 2. Nums at 1 will be 43. Nums at 2 is going to be 18. This highlighted portion is known as an initializer list. Think about what you would have to do in order to achieve this based on what we already knew. These two code segments are functionally equivalent, right? The left-hand side, I have the initializer list. I am creating an array with a length of 3 with these values. Based on what we previously knew, I would have to create an integer array with a length of 3, then go through and kind of manually set those values one at a time. Okay, so as you can see, this is a good quick way to create an array and fill it with values. So with that in mind, take a look at this double array called constants. I'm using the initializer list over here to give it values, but what is the length? What is constants at 0? What is constants at length minus 2? And then last, what is constants at constants.length? Okay, our length is 4. The element at 0 is 3.14, the very first one. Right? Length minus 2. Well, our length is 4, so minus 2. I'm trying to get constants at index 2. 0, 1, 2, 2.72. And constants.length is out of bounds. Because our indices start at 0, trying to access an element at length would be out of bounds. Specifically an array index out of bounds because we're going out of bounds in the array. Okay, so with that in mind, I'm going to flip over to Intro to Arrays. This is some Java code that we wrote inside of IntelliJ a couple of videos ago. And instead of doing this, I'm just going to quickly make an initializer list. All right, I'm going to comment this bad boy out. And I'm then going to create a double array called values using our initializer list syntax. All right, left-hand side, we have the variable being declared. The right-hand side, I'm going to use initializer list to not only give it a length, but give it some values, right? Something like 3.14 and 23. I can do that, right? Can you put an integer into a double? Sure. Okay. Of note, as we're going to see, why don't I make it values at 2, or I could make this one just an integer as well. Whenever this actually gets saved into the double array, it will be treated as a double for the remainder of the program. We'll see that because we're going to print off values at 2. I'm going to keep going. Let's see what we got here. 1, 2, 3, 4, 5, 6, 7. That should be pretty good. All right, I'm going to run this thing. All right, we still got the same stuff. So the first number we're going to see is the length of values. Where are they going to see values at 2? It's no longer a default value because we're giving it a value up here. I'm then going to change it to 23, and we'll see it yet again. So on and so forth. Okay. So the first number we see here, that is the length. We have 7 total values, right? 1, 2, 3, 4, 5, 6, and 7. The values at 2, 0, 1, 2, is a 7. Again, I can save an integer into a double, which is why this works. The vice versa would not work, right? If I tried to save a double into an integer array, I would have a problem. Our slides a couple of videos ago said compatible data types. And we're saying that the integer 7 is compatible with a double variable. But notice that once it's in the double array, right, whenever I go to print it here, it is 7.0. It is a double once it's in the array. Same thing with our 23. We then see, where's this coming from? Okay, yeah, I save in a 23 to values at 2 right here on this line. So the next thing we see printed is values at 2, and it is now 23. This is that square bracket syntax we can use to access and modify elements in our array. I try to access values at values.length -1. Our length is 7, so -1 is going to be 6. Values at 6, this is the last element. I'm making it 3.14. So this 98.6 becomes a 3.14, and we can see that on the next line whenever I actually go to print that off. And then everything else you see here was a result of the for loop, right? We used a for loop to traverse the entire array. We're starting at index 0, and we'll keep going as long as we're less than the length. With each iteration, I am just printing off the current element. So this is an initializer list. It is a quick way to declare and initialize, well, I guess really initialize your array. And it works for doubles. We've saw that in some of our examples. We also saw an example with an integer array. It could work with a Boolean array, right? If you're just curious, I'm not going to do much with it, but you could create a Boolean array. And in this case, the values that you're just saving in, because we're dealing with a Boolean, it's not numbers, right? If I try to save 23 in here, it's going to be very mad. But if I said true or false, that's what a Boolean is. So I can store those into the array. All right. With initializer list in mind, let's revisit some coding problems that we did the other day. The first one I'm going to look at is make pi. This one had us create an array with exactly these values, 314, and then return it. We made an array with a length of 3, and then manually changed the first element to a 3, the second one to a 1, the third one to a 4. Well, the initializer list makes this a little bit quicker. I could create an integer array. I'm going to call pi. And instead of being a new int with a length of 3, I'm going to use the initializer list to give it the values 3, 1, and 4. From there, I can return pi. Okay, comment in, sum 3, rotate 3. This is one that we could actually use the initializer list. They're actually kind of hinting at it in some ways. Right, they give us the original array, and they want us to, quote unquote, rotate it left. We're shifting the 2 and the 3 to the left, and then the 1 over here. Okay, I can use an initializer list here. What do I mean? I'm going to create an integer array I'm calling RTN. And I'm going to use an initializer list in order to give it its values. Okay, the first value of RTN is coming from nums, right? So think of this as RTN. Think of this as nums, because that is nums. So I want this value to come from nums at 1. I want this value to come from nums at 2. And lastly, I want this value to come from nums at 0. So the initializer list, this is a little quirky, but it works, right? I'm creating an integer array. I'm going to initialize it with these values. Nums is an integer array. Nums at 1 is a single integer, an element. Right? Again, nums is an integer array. Nums at 2 is a single integer. After I populate RTN, I can return it. Again, the initializer list made this a little bit faster. And the last one I think we can look at is reverse 3, which is where our last video left off. Similar situation, I'm going to create an integer array called RTN. And just instead of it being a new int with a length of 3, I'm going to use the initializer list syntax in order to give it values right away, as well as a length. And this one, we're reversing it, right? So this is going to be my RTN. This is ultimately going to be my nums. This value is coming from nums at 2. The next one is nums at 1. And our last one is nums at 0. So I'm just copying those values. I'm pulling them from the array. And there we have it. So that's an initializer list. It is useful for quickly getting an array up and running with some values. That's about it, right? We won't see much use beyond that, but I use it particularly in class to kind of demonstrate, to kind of get an array that we can quickly use and start actually operating on. With that, we're just going to move on with more coding back problems in the array 1 section. Here we have max int 3. Give an array of ints length 3. Okay, they tell us exactly 3. Figure out which is larger, the first or last element in the array, and set all the other elements to be that value. Return the changed array. Okay, there's nothing saying that I can't modify nums. I do need to figure out what is larger, but particularly just out of the first and last elements, not the entire array. So take a look at this example. We have 1, 2, 3. We're going to compare 1 to 3. We see that 3 is larger, so we replace all the elements with 3. 11 compared to 9. 11 is larger, so all the elements become 11. 2 to 3. Notice that 11 is technically the largest in the array, but we're only looking at the first and last element. Since 3 is larger, all of them become 3. All right, so my first step is to figure out what is the maximum. Okay, a couple of different approaches, right? You can start out with max. I'm going to set it to 0, which I don't think is going to be a good idea. We'll talk about why. If the first element in nums, well, what is the first element? The first element is nums at 0. If nums at 0 is greater than nums at 2, the last element, they tell us it's exactly a length of 3. If I didn't know what the length was, I could say nums.length minus 1. That should be the last element. But since it tells exactly 3, I can easily put a 2 here, right? So I'm going to say max is 0 starting out. If nums at 0 is greater than nums at 2, then I'm going to make nums at 0 the new maximum. Otherwise, if I hit this else, what it means is that nums at 2 is actually greater than or potentially equal to. So I'm going to save that into max. So when I reach this point, in theory, whatever the maximum is between this element and this element, it should be stored in max. So all I'm going to do is replace everything in nums with that. Okay, so we're going to say nums nums at 0 is going to become max, and nums at 1 is going to become max, and nums at 2 is going to become max. So doing all this, I've changed nums, but don't forget, we need to actually return an integer array. And I'm going to return the only integer array in this context, nums. Oh, really surprised that this turned out to be correct, because take a look at this. I set max to 0. What I'm worried about, what if the numbers are negative? What if all the numbers in my array are negative? I would start out by saying that the max is 0. I guess it's not a big deal. It's not a big deal because I'm just comparing the first and last element to each other. Okay, so we're fine here. They might have actually done that to me. No, I don't see any negatives. All right, I do want to streamline this a little bit because we can make it better. One thing we can do is start out by assuming that max is nums at 2. Pick one. It doesn't matter. Nums at 0, nums at 2. Based on what I have written here, I'm going to start out by saying my max is nums at 2. That'll allow me to get rid of this else, because take a look at this logic. we start out by saying max is nums at 2. However, if the first element, nums at 0, is actually greater than nums at 2, which is the max, then we update our max. This is effectively the same thing, right? Because if this is true, nums at 0 becomes max. But if it's false, then nums at 2 is still stored in max. I'm going to hit the go button to prove that that is correct. Okay. The last thing I'm going to do is actually rely on something that you've learned in this class, and that is some methods coming out of the math class. We actually have access to all of these things without having to import. I can determine what is the maximum between nums at 0, nums at 2. What this allows me to do is get rid of this if statement. This method is doing all the work for us. It is going to determine what is the maximum between the first element and the last element and return that value. I save that value into max and then use it to set all these other elements. And we see that there. Something that I don't think works, but what we could do. So let me show you what doesn't work. What if you tried to use an initializer list in order to set nums to a new array complete with the max values? It doesn't like this. Syntactically, this makes sense. Notice that I'm not declaring it, right? If I said integer array nums, this would be a syntax error. That variable already exists. It's the parameter that's coming in, okay? So in my mind, I just want to change nums. I want nums to stop being this array and start being this one. Of note, this initializer list only works whenever you're first declaring and initializing a variable, right? Reassigning the variable that I'm trying to do here doesn't quite work. But what I can do is create something completely different. Who says I have to use nums? I can do this. I'm creating a brand new array, and the value is just based on what is coming from nums. I then need to return RTN. And there we have it with our initializer list. So this is arguably the sleekest way to kind of solve this one. It relies on the math.max. And I'm using an initializer list here in order to even further reduce the number of lines. The last thing of note that I would not do, I'm using this variable like 3 times, and I think you can justify it there. But what if I just did it on the spot? You could do this, and as you can see, as I'm approaching this this recommended vertical line here, what that would allow me to do is get rid of the variable declaration. But what I end up with is a hot mess. It works. I do not recommend it. It is less efficient. It is definitely less readable. We could do something like this that kind of helps with the readability, but we still have efficiency issues, right? Because it is determining the max 3 separate times. This requires processing. Whereas my original solution, we determine the maximum value once, but then save it. So this comes at the cost of space, in theory. We save processing power at the cost of space. A very common trend in computer science. Let's check out the next one. Sum 2. Given an array of ints, return the sum of the first 2 elements in the array. If the array length is less than 2, okay, just sum up the elements that exist. Returning 0 if the array is the length of 0. Okay, so return the first 2 elements and then if it's less than 2. So something of note, if it's less than 2, there's either 0 or 1 elements, right? That seems like a kind of a no-brainer, but that's going to matter. We're taking in an integer array. We're ultimately returning an integer. That integer should be the sum of just the first 2 elements. In this example, we have a length of 3, but we're only summing the 1 and the 2. You see the returned value of 3. In this example, we have just 2, and so we get 2. In this example, even though there's 4, we're only, again, summing the first 2 elements, right? So typically, I like to kind of ignore these little special cases, right? If the length is less than 2, I'm going to try to handle the bulk of the cases first, which is just summing the first two elements. You could basically just say return nums at 0 plus nums at 1. Those are the first two elements. Boom. We're going to get a lot of problems correct based on that. But as you can see, if we got one element, we got a problem. If we got if we got 0 elements, we got a problem. So we're going to need an if statement. If nums.length, right? This will tell me exactly how long the array is. Note there's no parentheses here. We saw that with string. In the case of an array, it's not a method. Unfortunately, it is a public final variable that is stored inside of nums. If the length is exactly 0, I can return 0. Else if nums.length is exactly 1, and this is kind of what I would mean by if it is less than 2, that sounds like it's a big range of numbers, but it's only 2 scenarios. A length of 0, a length of 1. If it just is a length of 1, I can return the one and only element that is there, which is at nums at 0. Okay. Notice that I'm doing these before hitting this return statement. If I make it to this part, I'm guaranteed to have 2 or more elements, and we don't really care about the excess elements. We just care about the first 2, which we're doing here. This is the exact same as if we just did an else, by the way. But as you've seen with a lot of my solutions, I like to ignore that when I can. Let's move on to the next one. Given 2 int arrays, A and B, so they're sending us 2 of them this time, each have a length of 3, so we're guaranteed to have that. Return a new array length 2 containing their middle elements. Okay. We can use an initializer list here. Let's go. I'm going to create an integer array called RTN. And what we need to do is pull the middle element from A. That's going to go into RTN. We need to pull the middle element from B, and that's going to go into RTN. So the first element in RTN is coming from A. They tell us it's exactly a length of 3, so I know exactly where it is. This is the element in index 1. So I'm going to pull the element from A at index 1. Boom, that goes there. I'm going to pull the element from B at index 1, and it goes there. I'm going to return RTN. Come on, coding bat. You can do better. Let's go. Given an array of ints, return a new array length 2 containing the first and last elements from the original. The original array will be a length 1 or more. So in this case, they don't tell us exactly how long it's going to be. All right. We see here is our array. Here's the first element. Here's the last element. Boom. Here is our array. First element, last element. Boom. Okay. Very similar. I'm going to create RTN. And I'm going to use an initializer list. I'm going to pull the element from nums, the very first element. That is always index 0. They tell us that our length is going to be 1 or more, so I am guaranteed to have that element. Super important. Okay. If we had a length of 0 that was possible, this would potentially be out of bounds. We're going to get the last element. Now, the curveball here is they don't tell us how long it is, but that's okay. You know better. We can pull it dynamically by referencing the length. The last element of an integer array is always 1 less than its length, as long as it has 1 or more elements. I'm going to return RTN. Let's go to the next one. Has 23. Given an int array length 2, return true if it contains a 2 or a 3. I like this. Ultimately, we're returning a Boolean. We're taking in an integer array. This one has a 2. True. This one has a 3. True. This one does not have a 2 or a 3. We're going to jump all the way to the return statement because this can be just done at the point of return. I'm going to return nums at 0 is a 2, or nums at 0 is a 3, or nums at 1 is a 2, or excuse me, nums at 1 is a 3. Believe it or not, this is the solution I would recommend. They tell us the length is exactly 2, so I don't have to check anything on length. I'm looking at the first element. I'm looking at the last element, checking for a 2 or a 3. Next. No 2 or 3. Given an int array, return true if does not contain a 2 or a 3. You should do what I'm doing. I went back to the last problem that we just did. If this is not a 2, and this is not a 3, and this is not a 2, and this is not a 3, this is going to be super close. What happened? The way this reads, it says if the first element is not a 2, or the first element is not a 3. Well, one of these could be true while like the other is false. This is ultimately because I'm using the or. What I really want, if the first element is not a 2, and it's not a 3, and the last element's not a 2, and it's not a 3, right? I need all of these to be true. It's not a 2 or a 3. It's not a 2 or a 3. We're jamming. Let's go. Make last. Given an int array, return a new array with double the length where its last element is the same as the original array, but all the other elements are 0. This is important. The original array will be length 1 or more. Note, by default, a new int array contains all zeros. They tell us here. Boo. That was the big light bulb moment. If I create an integer array called RTN, and I do the new operator, the original syntax that we learned, it is going to be filled with zeros. Now, the question here is, what should my length be? It needs to be double what this one is, right? If we take a look at this example, this has a length of 3. This is a length of 6. This has a length of 2. This has a length of 4, right? So we're doubling the length. How can I do that? Math. I'm going to take the length of the incoming array and just simply multiply it by 2. Right? In the first example, the length is 3 times 2. That gives me my 6. That's going to create RTN with double the length, and by default is going to contain all zeros. So all I have to do is change the last element. Notice we're leaving the zeros in place. The only thing we're doing is taking the last element from the original array, sticking into the last element of my new array. So I want to update the last element of RTN. That is located at rtn.length -1. Right? Of note, this array that I'm making is going to have a different length than nums. So I need to make sure I'm referring to the correct array when I'm referencing length. I want this element to become nums at nums.length -1. Again, make sure you're referencing the correct length. So I'm pulling the last element from the original array, and I am putting it in the last element of my new array. After I make those changes, I can return my new array. And there we have it. I think this is going to be a good place to stop. Man, we just killed some coding bat problems. I'll see you in the next one.